Good evening. My name is Jason Maude, and I am the head of technology advocacy at Starling Bank. And what that means is I go around and talk about Starling Bank and the technology behind Starling Bank to people of various different types: developers, non-developers, people in government, industry, I've been working at Starling Bank for about 2.5 years now. I started there as an engineer. I turned up and they said to me, after I'd been there about a couple of days, just to get myself acclimatized, they turned to me and said, we don't have a direct debit system. Could you create one? Thanks. So I went away and wrote the direct debit system, which is a unique experience. If you have a chance to get involved with direct debit code, don't. Who here has heard of Starling Bank? Good. Majority of the audience. The number keeps going up. We are just down the road from the offices, so hopefully everyone here will have heard of it. Okay, what I'm going to talk to you about tonight is about the talk is called Securing and Speeding Up Java Services in the Cloud. So what I'm going to be talking to you about is about security and speed and how the two can go together. The problem with banking is that banks think that these two things don't go together. Generally speaking, for a bank, you can have one or the other. You can either be secure or you can be speedy. So we both started our talk off with a comment about tech culture and the sort of startup culture. And this is the epitome of startup culture, I think, the quote that epitomizes, for a while at least epitomized, startup culture. The quote by Mark Zuckerberg that you should move fast and break things. And I think the point of this quote was not to encourage people to commit buggy code or to release security flaws, but was to say, on occasion, you have to sacrifice, to a certain extent, quality in order to get code out in front of the customer. Getting code out in front of the customer is your top priority, seeing how it actually works in the real world. And that sort of knowledge you can only get by releasing code. And if that means that the code isn't precisely there, isn't all there, it has a few flaws, it has a few holes, a few gaps, that's fine, as long as you're getting code out in front of the customer. And then you can iterate quickly over that offering and get code out faster and faster and faster. But banks didn't like that, because banks are about security and reliability. Banks are about being there now and in 100 years' time and 100 years past. They're the sort of very traditional, signified by the Bank of England, the giant building with the big stone walls. Everyone knows it's going to be there. Everyone trusts it's going to be there. Because if people run out of trust in a bank, what happens is what happened to Northern Rock. Everyone queues up outside the bank to try and remove their money. And once a group of people start queuing up to try and remove their money, a load of other people look over and go, why are they removing their money? Ooh, I better remove my money from that bank as well. Can't be safe. And then you get a giant line of people outside the bank. And no bank, not any bank in the world, ever keeps enough money to pay back all its depositors at once. That's just not practical. You wouldn't be able to. That's not a bank. That's a safety deposit box. If you're doing that, you can't make money on the money that's been deposited with you unless you lend that money out. So no bank keeps all its money at the same time. So if people start mistrusting the bank, they say, oh, I don't think this bank's doing very well, and they start lining up to take their money out, that bank will quickly collapse. So trust is an incredibly important commodity for banks. And because the trust of their customers is paramount, banks rated security very highly and rated reliability very highly. And these two things together were put above all other considerations, including speed. And what that meant is that inherent conservatism in banking leaked into the way that banking did IT. When computers started becoming more and more of a thing and more used in banking, the conservatism of banking leaked into their IT. And so they did everything in a very slow, measured way. Releases of code happened once every 3 months, if that, and even that was a bit too, whoa, slow down, cowboy, you're going too quickly here. So everything was very slow, very laborious, and so on. But at least this slow, laborious way of releasing meant that banks never suffered IT problems of any sort. A few people in the audience caught that was a joke. That was a joke. Banks, of course, suffer IT problems. And what this slow release process means is that instead of having small problems with a reasonable frequency that get quickly squashed, what happens is that the banks have no problems for ages and then suffer a catastrophic outage, which takes the bank down for a month and means that they have to shut down online banking for ages. And they can't do anything, and everyone goes, well, what on earth are you doing? I don't trust you anymore. Who here has heard of this book, or read this book, seen it, heard of it? So it's getting a lot of traction and appearing in a lot of people's talks, including my own. This book is called Accelerate, and it's about what's called the science of DevOps. And basically the authors have gone through and analysed features of high-performing organizations. And one of the things that they identify about high-performing organizations is this idea that they get rid of this trade-off culture. They ignore just totally deny this idea that you can have security or you can have speed and you have to choose which one you have. They say no, and they go for both at the same time. They deliberately build their architecture in such a way that they can deploy features rapidly and get them out of the door quickly and be secure at the same time. So it's not a trade-off anymore. You try and get both at the same time. And this is what the sort of highest performing organizations, the big tech giants that we all know and love, try and do. They aim for this ideal. And Starling Bank also wants to go the same way. So before I continue, I'm just going to give a brief overview of who Starling Bank are and where we come from, which is important for what I'm going to talk about next. So Starling Bank describes itself as a tech company with a banking license. So we like to think of ourselves as a tech company first. We're a cloud-based bank. At the moment, we're mobile only. We're soon going to be releasing a browser-based interface as well, but we're entirely online. So there's no bricks and mortar branches anywhere. We don't have any of that. We offer all of the standard features of that a bank account, a current account can offer, plus some extra ones such as granular card control and aggregated spending data, and more and more all the time that are new, or at least were new when we started. We're finding that more and more incumbent banks are coming along and copying our features and going, look what we've done, fantastic. So that is what we offer. And we built this bank in a year, about a year and a half is more accurate to say. So we started developing in late 2015, and then in May 2017, which was in fact 2 years ago last week, we launched the bank into the App Store. And then in March 2018, we were awarded the Best Bank Award at the British Bank Awards. And then we repeated that in 2019. So we went from having no bank, and then a year and a half later having a bank launched in the App Store, and then 10 months later having the best bank. So the question is, how did we do that rapidly? How did we go through that rapid development of beating the incumbents, getting ourselves into this position where we were being declared the best bank by our users very quickly while still being secure. So, first I'm going to give you a brief overview of what Starling's architecture looks like, and then I'm going to go into discussing some of the architectural principles we implement in order to make sure that we are giving people that security while at the same time allowing us to deploy at speed. So we take a lot of our architectural principles from self-contained systems architecture, and there's a address down there if you want to read more about that. We haven't copied these principles in their entirety, but we've taken a lot of the ideas from self-contained systems architecture. So the way this works is that we have a lot of services, these self-contained systems, running. Our backend consists of a lot of these services running in the cloud. Each of these services, we wouldn't really call them microservices. We don't think they're small enough to be microservices, although how small is a microservice is an argument we can have later. But I tend to call them microliths. They're services that are designed to try and perform around a single area of business, like card processing, for example, or payment processing, or direct debit processing. They have their own database, they have their own business logic, and they have their own APIs, and those APIs can connect to perhaps the mobile, perhaps the management portal, which is what we call our management application, perhaps each other. So here's a picture of that. Now, these different systems have no startup dependencies between each other, so each of them can run individually. The system is mostly asynchronous. We try and keep the synchronicity to a minimum so that we can respond in a timely fashion to any requests that are being made by the user and give them feedback reasonably quickly that, yes, we will do this, and then process as much as we can asynchronously later, which does lead to itself to some challenges, some of which we will come on to. There aren't any distributed transactions between any of these services, so they all have their own autonomous transaction control within themselves. So we're not spreading the transactions out over the services, which means you have to be able to cope with the idea that things could fail halfway through. That you could, if a particular command that a user wants to issue needs to go across two services, that service 1 could complete what it needs to do, and service 2 could say, actually, no, I can't do that, and fail. And then you have to be able to recover from that position, which is interesting. We will come back to that one as well. So, there are several. We've got this set up. Now, what sort of principles of security do we have to consider when implementing this architecture in order to make sure that we are secure, in order to make sure that we can deliver that security that's needed? So, the first problem that you get with this sort of architecture where you've got many different systems interacting with each other, it was mentioned in a question on the last talk, which is what happens if these systems trust each other too much? If these systems trust each other too much, then you can get a problem where if one system gets compromised, then commands it's sending out to another system can be interpreted as, if the commands it's sending out from this system A, say, to system B are trusted, and system B says, well, it comes from within the bank, so it must be fine, then system B can be compromised as well, and system C and system D, and you can get sort of a spread like a virus of compromise going throughout the system, because you've managed to compromise one thing, therefore you've managed to compromise anything that it can talk to. So we need to make sure that we don't have this compromise going on. We need to make sure that we can put fire breaks in between these things. We need to make sure that we can check from one to the other. Now, part of the one of the benefits of not having distributed transactions is that you can make sure that you do this, right? Because you can have something happen in system 1, and then when it gets into system 2, and system 2 does a check and says, well, hang on a minute, am I allowed to do this? Should I be doing this thing? Should I be running this command? And it says, no, I shouldn't be. Then you are left with a discrepancy. System 1 says something has happened. System 2 says, no, it hasn't. And as long as you flag and highlight that discrepancy, then you can catch that there is a problem and you can go in and fix it. So in a way, having the system out of sync with itself is good because that raises the alarm that there's a problem and it can get someone to look into that problem. Let's go through an individual action and see how you can implement various different checks along the way in order to make sure that an individual action that you're performing has the correct level of trust attached to it. So, let's imagine that customer A has decided to make a payment of £20 to payee B. Payee is the word we use for another bank account somewhere that you're paying. So, customer A wants to make a payment of £20. Now, the first obvious question is, does this request actually come from customer A? So we've got a request in from the mobile to the customer system, which is handling the requests for payments that the customer wants to make. And our first question is, well, does this actually come from customer A? This request says it's from customer A, is it actually? Is it signed correctly? And so on and so on. So we can do that initial check. Fine. Do we trust it yet? Probably not. The second question we have to ask is, does customer A actually own payee B? Is payee B set up in customer A's address book? Or is this someone else pretending to be customer A? Customer A is a real customer, but they've somehow hijacked customer A and are trying to pay a payee that doesn't actually belong to customer A. The next question, obviously, is does customer A have £20 to spend? A fairly obvious one, but one that you have to check. So, do they actually have the money to pay it? And if they do have the money to pay it, let's lock that money very quickly. So, as I said, we try and do as little asynchronous processing as we can, but one thing that we have to do is if someone wants to spend £20 and we believe it is them trying to pay one of their payees £20, then we have to lock that £20 as quickly as possible. Because if we don't, then you could get the same person trying to pay the same £20 out to two different people at once. So you have to synchronously lock those funds down. So once we've done all of that, all of those checks and so on, and we've made sure that the person has actually got that £20 to spend and we've locked that £20, we're fairly trusting that this action is legitimate. However, we can still do more processing in the background. We'll allow that to go through. We've done all of the synchronous processing we need to do. But asynchronously, we can still do checks to make sure that this £20 is going legitimately out of the bank. So we can send a notification to the customer saying, hey, you've sent out £20. Now that might seem a bit silly because if I'm on my phone going, please send £20, sending me a notification saying, hey, you've just sent £20 may seem a bit weird. But if I didn't actually send the £20, then sending me a notification saying, you've just sent £20 will make me go, no, I didn't, what's going on? So I can check in. And I can phone up the bank and say, I think my account's been compromised. We also have reconciliation of accounts. We can check that the £20 went out to the correct place and it went out only once. And we can look back at that and say, well, it appears we have a £20 discrepancy in our accounts, what's going on here? And all of this involves multiple different groups of people looking at this simple transaction, right? It involves the customer looking at it through the notification. It involves the code looking at it from various different angles to say, is this combination of things that I have been asked to do a correct combination? Does it make sense as a whole? Do individual parts of it make sense? And we also have the overall accounting, the bank itself looking at its accounts and saying, do these all add up? So what's important to realize about this whole picture is that you can't just do, as we go back to our little circles going red all over the place, you can't just have one thing that you look at and say, is it safe, yes or no? You have to have multiple checks from multiple different sources looking at each individual transaction going, is this right? You have to look at it both in the whole as a holistic transaction, and you have to look at each individual bit individually. So, trusting a person. My next question to you is, would you trust this person? Would you let them have a bank account? Who would trust this person? Who wouldn't trust this person? We've already got a couple of people putting their hands up. Who needs more data? Most people need more data, and that's probably correct. Now, the question is, how much are you prepared to pay for that data? How much data are you prepared to pay for on this person to decide whether you trust them or not? This person, by the way, is what you get when you look for the stock image of a business person. So, stock image businessman, is he trustworthy? Well, we don't know. You can't just say from the picture. You have to gain more information on the person first, obviously. But then the question is, how much more? Once again, we're at a stage where if we want to work out whether to give this person a bank account or not, we can't just say, do we trust them, yes or no? We have to go, how much do we trust them? How much do we trust this person? And how much do we want to allow them to do? Now, this is especially important when you're a bank that doesn't actually meet any of its customers. We don't have any of our customers, we don't have branches which our customers come into and verify who they are. We're doing the whole thing digitally. So we can't look a person in the eye and say, are you Jason Maude? Are you really that person? Not that that might be considered a cast iron guarantee of someone's integrity anyway, but what we have to do is gradually build up a picture of whether the person is who they say they are through how they interact with the bank. So how we're ensuring security is we're going through, looking at how the person behaves. Are they, regularly transacting? Are they transacting in a particular way? Do they have a consistent pattern of transactions? And so on and so on. Various questions, various ways of looking at and slicing their data that allow us to gradually become more and more confident that someone is who they say they are. And as we gradually become more and more confident, we can gradually relax restrictions. We can start off by putting a lot of restrictions on what they can do in their account, and we can gradually loosen those restrictions as we are more trusting of what we have, of what they have given us and of what they are doing with the account. So this idea that, again, you can't start off with going 0 or 100, you have to gradually say whether you trust the person, gradually say whether this person is good or not, and you have to take this sort of risk-based approach of trusting the person or not, and you have to put that into the code. Much like you have put all of the checks on, the security of, did this come signed from the correct phone, and does this bit of data own this bit of data? You also now have to put checks in the code to represent these, the model of security of gradually becoming more and more trusting of a person. And then, would you trust this mule? That's the next question. So, going beyond trusting an individual person is trusting patterns of behavior that replicate themselves across multiple groups of people, multiple people. The reason I put a mule here is one problem that all banks have to deal with is the idea of mule accounts. A mule account is a legitimate account that has been set up by a person who is, perfectly honest and decent, which gets taken over somehow, either through technical trickery or through social engineering, gets taken over by a criminal who then uses the account to launder money, commit fraud, etc., etc. Now, the problem is that this mule account might suddenly go from being a legitimate account to an illegitimate one, but it might not. It might remain the legitimate account of the person using it. They keep going out and spending on their card and so on and doing all of the regular things that make them a trusted account. But every so often, a large payment will come in and several smaller payments will go out, or several small payments in and a large payment out to essentially launder some money obtained through crime. Spotting these accounts for banks is very difficult because to all intents and purposes, they behave like legitimate accounts and the person has been verified. So how do you detect them? And the answer here is you have to detect them through trends. You can't just detect them by, again, looking at narrowing your vision down to looking at the individual person. You have to expand your vision out to looking at all of the connections that account has, the connections to other accounts, and are those other accounts trusted or are they not? Have we got information that those are bad accounts? So once again, the principle comes in of you need to not only look at the individual parts, you also need to look at what you're doing as a whole. This is where, although I'm not going to go into this right now, it's a talk for another time, but this is where things like machine learning and AI can play a big part in what you're doing, because you can start teaching the machine to spot trends of bad accounts faster than a human can spot them. And this is where machine learning can really come into its own and can really give you the heads up quicker than you would have caught it yourself that something is going wrong either in this particular group of accounts over here, or it can spot trends of unusual spending behavior that happen, that you wouldn't even realize is a new type of financial crime. But over here, there is a new trend of spending patterns happening that's odd. Look into them. And it might be that those spending trends are happening because it's a bank holiday or it's the World Cup or something like that. And you could easily just go, that's fine. But it might be that they are actually some form of financial crime in the continuing game of cat and mouse between fraudsters and those who try and catch them. We also have to be able to, overlying all of this, the code and what we're putting into the code to make sure that the code is being mistrustful, the code is checking and rechecking everything at every stage. We also have to make sure that our system of deployment is, the way we get code out into production is good. And this is where we come back to speed. In order to get code out fast, we have to be able to make sure that we are, have an efficient deployment process, a deployment process that allows us to move code very rapidly from development into demo environments into production without too many delays along the way. But we need also to make sure that that's being done in a secure manner, in an auditable manner. We've spent a lot of time at Starling putting effort into what we call chat ops, where we have used Slack in order to try and enable that security, be that the auditing of doing releases and recording what is in a particular release, what code is going out in a particular release, or, as is demonstrated here, the granting of roles and permissions in the AWS console. the person who wants to deploy the code can't just give themselves the role. They have to go out and say, could someone give me the role? And then someone else has to give them the role. And then they get the permission granted, and then eventually that permission times out and is removed from them. There are various different levels of permissions, from ones that grant you a little bit of access all the way through to ones that grant a lot of access. And obviously the ones that grant a lot of access are more locked down and are more obtainable only by particular people. So, what are the key takeaways of what I've been saying? So first off, I'd like to come back to this initial point that there isn't a trade-off between security and speed. If you implement all of these principles I've talked about in an automated fashion in the code that you're writing, rather than, as most banks do, allowing them to be implemented by humans using pieces of paper, but if you actually implement them in the code you're writing, there isn't a trade-off between security and speed. You can be speedy, you can deploy quickly, whilst at the same time remaining secure. In order to do that, you need to design your software to be skeptical. You can't just have the hard outer shell, which is your wall, and then the soft inside. So you need to make sure that each service along the way is checking what it's doing. Each service along the way is checking, am I doing the right thing? Have I already done this thing? Does whatever is asking me to do this thing have the permission to do this thing? Having these different services handling things and being able to have essentially a disagreement between two different services about what the state of play is good, because that reveals to you, as long as it's noisy enough, as long as it doesn't fail silently in the background, as long as you've got alerts on it and alarms and graphs and so on pointing out that there's a problem, you can go in and investigate and say, why are these two services disagreeing about whether this payment should go out or not? Machines can spot patterns faster than humans if you train them properly. There's a whole nother presentation about mistraining machines to spot patterns in the wrong way. But if you train, but one of the great things about machine learning is the ability for the machine to spot abnormal patterns of behavior faster than you could. And that is, where they can really come into their own in helping stop security breaches and stop financial crime. And finally, I think this is probably the biggest takeaway: trust is not a binary characteristic. You can't just say something is trusted or not trusted. You have to take a scale of the 50 shades of grey from not trusted at all to totally trusted, but you'll probably never be at one of those extremes. You'll probably be somewhere in between those. And you have to, and it's not the case that if you're 51% trusted, then you're trusted, and if you're 49% trusted, then you're not trusted. You have to gradually increase what is available, what is allowed, what is permitted, what is can just go through on the nod as that trust level goes up. Thank you very much.